Okay, let's see if the rooting hormone type and concentration has an effect on roses and their ability to root cuttings. So what I've done is I've just pulled up a bunch of articles, and these were just the first ones that popped up in that search of just rooting hormone for roses. So I'm not going to go through a deep dive. What I'm going to do is look to see in their tables or in their conclusions what rooting hormone had the best results for them. So in this first one, we're looking at Naa and Iba concentrations on some different rose cultivars. So keep in mind that the number of roots will differ depending on the rose cultivar, but for any given rose cultivar, I believe you should be able to see which rooting hormone has a greater effect. So let's scroll down, see what this one has. So it looks like they're using 500 and 1,000 parts per million for Naa and Iba. Increase of Naa concentrations from 500 to 1,000 was followed by a significant increase of rooting percentage. So it sounds like for Naa, 1,000 is best for this one, but that was also their limit. So let's scroll down to conclusions, see what they've got. Maximum rooting percentage was recorded by using Iba 500. Longest roots were for Iba at 1,000, but the strongest and healthiest roots were back at 500. And Iba concentration seems to be more effective than Naa. So a lower concentration of Iba seems to have the greatest effect. Let's keep going with other articles. This one's looking at, again, Iba, Naa. Maximum root length was observed. Again, Iba 500 parts per million. Highest number of leaves, 500 parts per million for Iba. Highest number of buds was 1,000 parts per million of Iba. And that was for rose cultivar. So again, 500 to 1,000 is looking good. Another observation is these papers aren't going above 1,000 yet. Here we've got, again, Iba for damask roses. Let's see what they do. Have a quick look at the tables. Iba and genotype. I'll zoom in it all here. So these look like your controls. They're applying 0% of Iba. Percentage of rooting, it's down around the 20s and 30s for a few different cultivars. Then you're looking at 500 parts per million. That puts it up to the 40 to 60 mark. 1,000 is you got 60, 40, almost 80. So the 1,000 is looking a bit better here. Scroll down to their, their conclusion. The current study demonstrates that the different genotypes are in a difficult to root state, suggests that cutting treatment of 1,000, so 1 gram per litre of Iba overcame the problem of difficult to root state. So your 1,000 parts per million is used if you're having trouble rooting the cuttings. This one is, again, Iba on stem cuttings. So I'm not having an actual read of these articles. I'm just looking for key bits of information. This one here looks like the Iba concentrations. They go up to the 3 grams or milliliters per litre or kilogram, depending on if it's a powder or gel. So when it says, let's say if an item was 3 grams per litre, that would be equivalent to this 3,000 parts per million number that they're stating here. Do they have a table of what they're after? IBA concentrations, NRPC, what's that? So NRPC, number of roots per cutting. Here we go, softwood, semi-hardwood, hardwood. I believe that's what they would be referring to. Yes, softwood, semi-hardwood, and hardwood. Awesome. Okay, so IBA concentrations. Yep, for the softwood, 1,000 parts per million seems the best. It's pretty close to your 2,000 parts per million. So not much of a difference there. Semi-hardwood, what are we looking at? Seems to peak at 1,000. No, peaks at 2.5. And then your hardwood, you got your 1,000 again for hardwood cuttings. That's interesting. I would have thought hardwood, the higher the IBA, the higher the number of roots. That does not seem to be the case. I think that is supposed to just be hardwood, not semi-hardwood there. So you've got 30, 34, and 30 as your controls. You're then looking at 1,000 seems to peak for the hardwood. So for hardwood, I'd actually be going from 1 or 2 grams per liter. Process of elimination, what's the best for all of them? So we got 1 and 2 for the softwood. Out of the 1 and 2, which one's better? 2 is better for the semi-hardwood. And 2 is also okay for the hardwood. So it looks like 2 grams per liter of IBA is going to be the best. In the case of leaf number, the highest number of leaves was produced from hardwood cuttings treated with 2,000 parts per million of IBA, followed by semi-hardwood cuttings of 2,500. Semi-hardwood cuttings treated with 2,500 parts per million produced the highest number of roots, followed by hardwood cuttings treated with 1,000. Yeah, so I said that as well. So 1,000, the hardwood cuttings, in terms of everything else I've heard from YouTube, indicated that for hardwood cuttings, you want a higher percentage. This is still saying 1,000, the hardwood cuttings, but you can see that's not actually too much different from the 2,000. So I think 2,000 is what to aim for. Now, I've also pulled up a bunch of different rooting products to see what these ones have to offer. So this is what I was using. The reason behind that was I'd been watching lots of American and Canadian YouTube videos about rose cuttings, and they were saying that there wasn't much of a difference that they had observed between the powdered form or the gel form of the rooting hormone. And so I decided to just use the powdered form because you can get through more cuttings without wasting the product. But in Australia, the powder form and the gel form of the rooting hormone have different things in there, whereas a quick look at the American products, they have roughly the same thing. So in this one here, we can see that you've got IAA at 500 parts per million, and then you've also got this NAA at 200 parts per million. Now, we hadn't really had a dive into these, but those articles were mainly focusing on IBA for rose cuttings. Now, this is the gel form of the stuff that we can get in Australia. 3,000 parts per million of IBA, or 3 grams per litre. One of the good levels as seen in the publications. Clone X, IBA, again, 3 grams per litre. Root XP, plant cutting powder, 3 grams per kilogram of IBA, should do the exact same thing as those other two. Root XG, 4 grams per litre. It's getting a bit high. What's this? Hardwood Yates, it looks like, it's hard to tell. Is that an 8 grams per litre? That's looking pretty high. Easy Root, you have 1.6 grams per litre of IBA, or is that 1.5? Anyway, it's approximately 1.5 grams per litre of IBA and the NAA. That's the lowest concentration of IBA that I've come across so far. So really any of these should work. This one, not so much based off of the research. And that's kind of what I've been seeing as well. When looking at the air-layered cuttings with this powdered form, callus, but after 3 weeks, they don't have lots of roots. The air-layered cuttings with this gel after 3 weeks are just exploding with roots. And I think that's based on that research, it's to do with the IBA. So you can see 3,000. Now I was using semi-hardwood cuttings and we're up at the 52 mark. For softwood, you're a bit lower. You're halfway between your control and your semi-hardwood. But if I could get to 2 grams per litre, I should be able to still root my semi-hardwood, but also root the softwood. So those cuttings that are closer to the flower, cuttings that if a new branch has come out with a flower on the end for a hybrid tea, I should be able to take that cutting earlier. Some of the ones that I had thought were ready were too early. So with 2 grams per litre, should have a higher chance of getting those to root. It's hard to find this 2 grams per litre. Unless I want to make it myself, I'm kind of stuck with either 3 grams per litre or 1.5 grams per litre. Now going back to this article, 1.5 on softwood is 45, 41 on semi-hardwood, and 46 on hardwood. 3, hardwood is 43, semi-hardwood is 52, softwood is 43 again. So you really have to find that semi-hardwood cutting if you're using that 3 grams per litre. What I could do, because I can't find 2 grams per litre, is I could get this 1.5 grams per litre and this 3 grams per litre and just mix them together. So what is a 50-50 ratio? So if I have 1.5 plus 3 divided by 2, I'm looking at somewhere between the 2 and 2.5. The softwood, it's still around its peak. For semi-hardwood, that's still around its peak. For hardwood, you have a dramatic drop off. So if I'm looking at just the hardwood cuttings, I'd use just the 1.5. because I also can't find the 1 anywhere. And for softwood and hardwood, I would use a combination, so a 50-50 split of just the 1.5 and the 3. Yeah, so I'll do that to be able to optimize percentage of cuttings that will root.